This is a typical statistics class at UBC. Traditionally, the students are expected to simply listen to the professor speak while taking notes. Teaching techniques have often remained quite unimaginative. That is, the professor giving the lecture while the students are simply expected to listen and then apply the information. Is this really the best way for students to learn and for teachers to teach? Research going on right here in UBC is attempting to show that there may be better ways. Our time with researcher Natasha Holmes is intended to give us a glimpse of these new ideas.
So we started the study on an assumption that invention activities were good for learning and that they would help students learn some of these data analysis skills is the main thing that we were looking at in the course. So what we wanted to look at was, we had noticed sort of in the classes that students, we gave them these cool contrasting cases, we call them, where we give them some data sets that they can use to build their inventions, and they're sort of strategically manipulated so that they can learn about the content through those cases. So we found sort of just through observations is that students weren't necessarily using those cases unless, well, no, they weren't necessarily using the cases. So we wanted to see if we could get them through that process and then if that would help with their inventions in the end. So we added this sort of, we called it scaffolding. It's really just sort of guidance through expert behaviors about what an expert, if they were given this task, how an expert would go about solving the task.
We then had Natasha perform the experiment on us, so we would have a better understanding of the research that she's been a part of.
I've also got Excel open here if you need to do any calculations or anything.
Okay.
And if you want to skip the calculations, that's fine.
For that, a separate equation. It won't be the same.
It won't be the same.
What? What are you trying to invent?
We are so confused.
Now, what is metacognitive scaffolding?
We called it scaffolding. It's really just sort of guidance through expert behaviors about what an expert, if they were given this task, how an expert would go about solving the task. And so we gave them some of those things, and the main one is to make comparisons between these two cases and decide which one's better or not, and then just explain why, to start to extract some of the reasons that things are the way that they are. So the conclusion was that we found that that structure really did help students in their quality of inventions, and then also to reason about how their inventions worked or didn't work, or what they were trying to do, talking about the goal.
More students joined in on the decision-making process. This allows more people to have input in the final decision, making it more productive than working alone or with one other person.
It's going to get the best average, right?
Then we should look at the data, or else you won't be able to know how close we are.
Because this gives us what the X and Y are,
Yeah.
right?
So we
Well, there's going to be, I guess, the difference between the plotted point and the point best fit.
So what does that look like mathematically?
That looks like function of x minus x.
Okay.
Where x is,
How does that make everyone feel?
or is it x minus f of x? It's technically the same thing.
After a while of struggling, Natasha Holmes came in and tried to guide us in the right direction.
So your formula was, so what's one way that I could fix that? I could make it so that this line is in fact better than that line.
Was it the absolute value?
Something like that would work. You actually mentioned that in your discussion. You said taking the absolute distances.
In summary, the purpose of this research is to illustrate that teaching strategies such as getting information across is not the efficient way to engage students in learning. An effective way is to make students invent a solution to the problem. Along the way, students will struggle, and that's when teachers should come along and guide them. By doing so, students will learn much more effectively on how to solve certain problems.
As students, I hope that students can look into this research and realize that there are better ways to learn than being told. It's about that transfer of information isn't the best way to learn, and that really it should be about creating knowledge. And if you get there first, that's really going to help you learn. For the system, I hope that they also learn that, but what our research does kind of uniquely, not just saying, oh, inquiry learning is good, but it's that students need help learning these inquiry skills. Like doing that discovery is a tough thing to do. It really is expert behaviors to go through that reasoning. So they do need support in getting from point A to point B. Let them discover it, but help them along the way.